Hello. Today we are going to discuss about diodes, how it works, its history, its characteristics, and its different types. Diode is a semiconductor device, and we will tackle this first since every other semiconductor is basically made from combinations of diode. So these are the different types of diode, and we will learn later that it has their own functions. The concept of a diode is that it is a two-terminal electric component which conducts current more easily in one direction than in the opposite direction. Okay, so this is a typical example of a diode and it has a length of 4 millimeters. So this tiny silicon chip here is the diode. Now, the symbol for diode is just like this figure. So the direction of the arrow means that this is the direction of a forward current, or this is the direction of your current, okay, from positive to negative. So if you have a diode and you will connect this to a circuit, take note of this mark, okay? So this mark here signifies that this is the cathode part, and also this is the cathode part, and the opposite here is the anode. So you cannot interchange this one since the if you interchange this, there is no current that will flow. Let us now discuss the history of diodes. In 1873, Frederick Guthrie discovered thermionic diodes or vacuum tube diodes. So the concept of these diodes is that heating the cathode in forward bias permitted electrons to be transmitted into the vacuum, but in reverse bias, the electrons were not easily released from the unheated anode. So this is a typical sample of a thermionic diode. In 1874, Carl Braun discovered the first solid-state diode. This is the crystal diode, and it consists of galena crystals as the semiconducting material. So this is a crystal diode, and actually this is a galena cat's whisker detector. This is an early radio wave detector used in crystal radio receivers from about 1905 to the 1940s. The fine metal wire attached to the adjustable arm touches the face of a natural semiconducting crystal of galena. This is the lead sulfide now. In the capsule archive, the contact forms at the junction, making a crude semiconductor diode. In a crystal radio, its function is to rectify the alternating current radio signal, extracting the audio or sound signal from the radio frequency carrier wave. In 1904, John Ambrose Fleming invented the Fleming diode. It was constructed with two electrodes in the form of a vacuum tube. In 1906, Lee D. Forrest added a third electrode, called a control grid, and the triode, which is used as amplifier. The application of triode created a new era in broadcasting with the invention of the crystal radio sensor by Picard in 1912. So it is commonly used in DC power supply units as a rectifiers and voltage regulators, clipper, and clamper circuit. And it comes in different shape and sizes. So in 1919, diodes were known as rectifiers, when a physicist by the name of William E. Clay coined the term diode, which from its Greek roots means through path. But in 1939, Russell All discovered the first p-n junction at Bell Laboratories, and today the majority of diodes are made of semiconductor silicon p-n junctions. One way to understand how a diode works is through the IV curve, or the current voltage graph. Now, let us consider a perfect diode or an ideal diode. The key function of an ideal diode is to control the direction of current flow. Current passing through a diode can only go in one direction, called the forward direction. The current trying to flow the reverse direction is blocked. They are like the one-way valve of electronics. So take a look at this figure. This is the IV curve of an ideal diode. So if the voltage across a diode is negative, so this part, no current can flow. And the ideal diode looks like an open circuit here. So when we have an open circuit, our current is zero. Okay? So in such a situation, the diode is said to be off or reverse biased. As long as the voltage across the diode isn't negative, here, okay, this part, it will turn on and conduct current. Ideally, a diode would act like a short circuit, meaning there is no volts or voltage, meaning 0 volts across it, if it was conducting current. When a diode is conducting current, it's forward bias, meaning the electronics jargon for on. So as shown at this table, it shows the summary of the characteristics of an ideal diode. Unfortunately, actual diode behavior isn't quite ideal. Diodes do consume some amount of power when conducting forward current, and they won't black out all reverse current like this. Okay? Real world diodes are a bit more complicated, and they all have unique characteristics which define how they actually operate. If we have a real diode, as shown at this figure, particularly a silicon diode. A silicon diode actually does not conduct to a slight positive voltage, and it would go up like that at around 0.7 volts. And this is a good IV curve of a diode, and this is an example of a nonlinear device. If you recall the IV curve of a resistor, which is a linear device, it looks like this. Okay, let me have my pen. So the IV curve, sorry, okay, so let's assume that this is a straight line. So a line that went through a zero and had a constant slope. Okay, so that is for a resistor. So depending on the voltage applied across it, a diode will operate in one of three regions. First is the forward bias. Here, when the voltage across the diode is positive, the diode is on, and current can run through. The voltage should be greater than the forward voltage. 1. In order for the current to be anything significant. Forward voltage might also be called either the cut-in voltage or on voltage. While for the reverse bias, this is the off mode of the diode, where the voltage is less than the forward voltage, but greater than the negative of the breakdown voltage. In this mode, current flow is mostly blocked, and the diode is off. A very small amount of current on the order of nanoamps, called the reverse saturation current, is able to flow in reverse through the diode. While for the breakdown part, when the voltage applied across the diode is very large and negative, lots of current will be able to flow in the reverse direction, that is, from cathode to anode. Now, let us discuss the different types of diodes and its applications. Let's start with the power diode. A power diode is used as a rectifying power supply circuit, while the signal diode is used as a signal sensor in radar. So we have small signal diode and we also have large signal diode. The large signal diode have large p-n junction layer. Thus, the transformation of AC to DC voltages is unbounded. And this also increases the current forward capacity and reverse the blocking voltage. So for the Zener diode, this is a voltage regulator in power supply circuit. And this diode is designed for limiting the voltage across its terminals in reverse bias. and it maintains a nearly constant voltage across its terminal over a specified range of Zener currents. For the LED, this is the light-emitting diode. LED emits light when forward biased, and these LEDs are available for either infrared or visible light. Actually, the high-intensity LEDs are used in large screen displays, in traffic lights, automotive lighting, and home lighting. For the tunnel diode, this is used in the oscillator circuit in an oscilloscope. So, the tunnel diode exhibits a special characteristics known as negative resistance, and this feature makes it useful in oscillator and microwave amplifier applications. For the varactor diode, this is a variable capacitor in a tuned circuit. So, a varactor is a diode that always operates in reverse bias and is doped to maximize the inherent capacitance of the depletion region. The depletion region acts as a capacitor dielectric because of its non-conductive characteristics, and the P and N regions are conductive and act as the capacitor. As a continuation, the Shockley diode has 4 layers. It is also called as PNPN diode. It is equal to a thyristor without a gate terminal, which means the gate terminal is disconnected, as there is no trigger inputs. The only way the diode can conduct is by providing forward voltage. It stays on once it turned on, and stays off once it turned off. The diode has two operating states, conducting and non-conducting. In non-conducting state, the diode conducts with less voltage. For the photodiode, it is a light sensor in a remote control unit. The photodiode is a device that operates in reverse bias and exhibits an increase in reverse current with light intensity. A diode in which the reverse current varies directly with the amount of light. The photodiode has a small transparent window that allows light to strike the PN junction. Here, when its PN junction is exposed to light, the reverse current increases with the light intensity. When there is no incident light, the reverse current is almost negligible and is called the dark current. For the Schottky diodes, they are high current used primarily in high frequency and fast switching applications. They are also known as hot carrier diodes. It is formed by joining a doped semiconductor region, usually n-type, with a metal such as gold, silver, or platinum. Here, for the laser, the term laser stands for light amplification by stimulated emission of radiation. Laser light is monochromatic, which means that it consists of a single color and not a mixture of colors. Laser light is also called coherent light, which means a single wavelength. And these laser diodes are also used in laser printers, fiber optic systems, and used for the treatment of cancer. For the last example of different types of diode, the PIN diode, it consists of heavily doped P and N regions separated by an intrinsic region. When reversed biased, the PIN diode like a nearly constant capacitance, while when forward biased, it acts like a current-controlled variable resistance. The low forward resistance of the intrinsic region decreases with increasing current. That is all for the overview of a diode, and let us end here. We will continue our lessons about semiconductor devices next time. See you!